coordinate proof and congruence and overlapping triangles. So we're going to kind of combine two concepts here. So coordinate proof is a logical argument in which a figure is drawn on a coordinate plane, and the formulas for slope, midpoint, distance are used to prove the properties for the figure. So we may have points like h comma 0 or 0 comma k. We may not have nice like numbers in those formulas. So number one, so we used graph paper, we did this. It says which of the ways that you place the triangle is best for finding the length of the hypotenuse. So we talked about how it was convenient to place a triangle here. So we would have like 3 comma 0 and 0 comma 4, because if we were doing the distance formula, we had zeros in it. So you should have had something that looked like the distance formula. You'd have like 3 minus 0 squared plus 0 minus 4 squared. And we like having zeros, right? So did you guys all get a distance of 5? So when it says place a 3 by 5 unit rectangle on the coordinate plane, I would place it so that one of the sides is along that, or both those sides are along the x and y axis. So if I do 3 by 5, I'm going to go over 3, up 5, and I'm going to place it like that. So then my points are going to be 0, 0, 3, 0. What will this one up on the top right corner be? 3 comma 5, and then what about this other one? 0 comma 5, right? Over 0, up 5. Easy enough? All right, and then you can prove different things about this. So if I asked you to find the midpoint of the bottom base, right, you would do the midpoint between 0, 0 and 3, 0. So it'd be 1.5 comma 0. You can prove different things. All right, so number 3. So it says a right triangle has legs of 6 and 8 units. Place the triangle in the coordinate plane. So I'm going to go over 1, 2, 3, 4, 5, 6. And I'm going to go up 8. Okay, and I'm going to get this little triangle drawn in. Okay, it's told it's a right triangle. So it says label the vertices and find the length of the hypotenuse using the distance formula. So again, we have 0 comma 0. We have 6 comma 0. We have 0 comma 8. So remember, the distance formula is really just the Pythagorean theorem. Okay, so when I talk about x2 minus x1 squared and y2 minus y1 squared, what we're saying is, what's the distance between our x's? What do I get when I subtract those? I get 6. And then it's like, what's the difference between our y values? It's 8. Okay, that's where that's coming from. So you can plug in your points if you want to. You'd have 6 minus 0 squared. So if I'm finding the distance between these 2 points. And then I'd have plus 0 minus 8 squared. So it's okay that it's negative 8, because when we square it, it's the same as 8 squared. Okay, it doesn't matter what order you do that in. Yeah. You totally can, because that's all it is. It's Pythagorean theorem, right? It is. Do you guys know what it is right away? Ah, good. You noticed it was a 3, 4, 5, right? You're learning so much in geometry. Even though it's gone fast, you're learning a lot. All right, perfect. So it ends up being 10. All right, so it says in the diagram, triangle EGD is congruent to triangle FGD. Okay, so do we see those 2 triangles? Find the coordinates of point G. Do not make assumptions from the picture. So don't assume that it's in a certain location, because I think this picture is not very good. All right, so if I'm trying to find the coordinates for point G, well, what do we know? We know that these triangles are congruent to each other. So shouldn't FG, shouldn't that be the same as EG? They should be the same length, right? So if those are the same length, that point G that's in the middle is called what? The midpoint, right? That's how I helped you along there. I said middle. Midpoint. It's the midpoint. So how do I find the midpoint? I just find the midpoint by doing x1 plus x2 divided by 2, y1 plus y2 divided by 2. I think this picture actually is good, but okay, so I'm going to do 0 plus negative 5 divided by 2, and 5 plus 0 divided by 2. So I get negative 2.5 comma negative 2.5, or positive 2.5. What am I doing? Does that look like where it is? Looks pretty good, right? I think I said don't make assumptions from the picture because I didn't want you to just be like, oh, it's negative 2.5, 2.5, which it is. But all right, does this make sense? Sarkis? Sarkis. Write some notes down. Okay, so number 5. So how would you prove or write a plan to prove that OU bisects TOV? Okay, so we have all these different points. So sketch all the points in. So we have negative 3, 5, 0, 5, 3, 5, and 0, 0. And I would label the points as you go. It will help. Okay, so we want to prove that OU bisects angle TOV. So here's TOV. How can we prove that this segment bisects it? So what do you guys think? So we haven't talked about how to find angles. There is a way later on that we're going to learn. It's called SOHCAHTOA, where we could find those angles. We don't know how to do that. But think about what we've learned in this chapter. We've been talking about congruent triangles. What can we do? Yeah, Roman's getting close, I can tell. He's like, wants to raise his hand. Okay, so I'm going to draw this line in to help us. You can say, so OU congruent to itself, so reflexive property, right? So he's saying OU is congruent to OU. Yeah. What else can we say? Can we say that TU is congruent to VU? And why can we say that? Can you tell from the picture? How many units long are they? Yeah, they're both 3 units. They have the same measurement, right? Can we say any angles are the same? You could probably even tell me the degrees on a couple angles, right? TUO, what's angle TUO? Isn't it 90? VUO is 90, right? Do you guys see that? So angle TUO is congruent to angle VUO because they are both right angles. So then can we say that the triangles are congruent by side angle side? So triangle TUO is congruent to triangle VUO by side angle side. And then are we good? So then we can say angle, what 2 angles do I need to be the same? I'm trying to say that OU bisects angle TOV. So we're saying TOU is congruent to angle VOU by, good job, Austin, good. The rest of you guys have all those letters straight in your mind? And then therefore, what were we trying to prove? We were trying to prove that OU bisects angle TOV by definition of angle bisector, right? That's our proof. Does this make sense? All right, so next one. So it says, use a paragraph proof to show that triangle OPQ, so let's draw on this little line here. OPQ is congruent to triangle QRO. So we want to prove those 2 triangles are congruent to each other. So again, you could do the easy one first. You could say that OQ is congruent to itself. So you could do QO if you want, or just call it OQ again, by reflexive property. We always say reflexive property of congruence if we're using a congruent sign. But if it's equal, then we say reflexive property of equality. But I'm fine if you just do reflexive property. You don't have any numbers. These are not like actual, like I can't count. These aren't actual distances. Like it's not like 3 units or 5 units or whatever. So I can't count and be like, okay, this is up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not up 12. It's up by how much? I think this is supposed to be an H. N? I think it's an N. My handwriting's not very good. We're going to say N. Okay. So lots of different things at our disposal. We could use slope to show that lines are parallel. We could use the distance formula. What do you guys want to do? I think these are both N's. And then I think these ones are H's. So we could use the distance formula, or we can kind of count in a weird way. Yeah, Roman, what do you think? Can you see what distance is separating these? How many units is separating that? Not 12, but think about our points. N. Do you guys see that? That's N. So there are N units between those. Is it the same over here? So we go from a height of K to a height of K plus N. Yeah, would that be N units? Yep. Good there. So we at least know that these two are the same, and we knew that this was the same as itself. So how about these ones here? Can we get that those are the same? But we can't use those actual points. We don't know what 1 is. It's really, they really have a slope of, we rise up from N to K plus N. We go up K, and we go over to the right how much? H. So the slope is really K over H, right? Is the slope also K over H? So if I go from 0, 0 to H comma K, do I go up K over H? Yeah, the slopes are both K over H, right? So our slope is K over H. So if our slopes are the same, could we say we have parallel lines? Yeah, we could say the lines are parallel. And then what 2 angles would be the same then? It looks like this one and this one would be the same, alternate anterior angles. Does that work for us? It doesn't. It spells out the bad word ASS. So it didn't help us. But if we could get that this one and this one are the same, then we have side, angle, side. So can we get those angles are the same? Can we find the slope of these lines? What is the slope of those lines? Undefined, right? So that means that those 2 lines are parallel as well, which means that this angle and this angle are congruent. Then we're good. We can say side, angle, side. Does this make sense? Okay, so we need to kind of write this down. That's the annoying part. It's like we pretty much have it, but we gotta show it. So we had our reflexive property. We're good there. We can say that our slope of what point was it? OP and what was it? KQ is undefined, which means OP is parallel to KQ. So then the triangle, or the angles, POQ is congruent to triangle, or angle RQQ. QO by alternate interior angles. The distance, so if I want to write the distance between O to P, if I want to show that's N, I write it as OP without a line on it, is N, and RQ is N. That means that OP is congruent to RQ, right? They're the same measurements. So then our triangle OPQ is congruent to triangle QRO by side angle side. Okay. Does that make sense? No worries, you don't have one like that on your quiz. It's pretty tricky. All right. You can have things with numbers, but it's hard when it's like that. All right, so let's move on to the overlapping triangles. So sometimes you have overlapping triangles. So let's find all the missing angles. So this little angle D, this should be over here, angle D. Okay, so let's see. So let's first talk about this triangle right here, so XYZ. We have two of the measurements. We have 35 and 89. So are we able to find angle XYZ? Sure. We do 89 plus 35, and we subtract it from 180. We end up getting that this angle is 56 degrees. You see how we're going to do this? All right, so let's look at another triangle. So I'm going to circle this other, or I'm going to outline this other triangle in blue. Do we have angles there? Yep, we have 89 and we have 59. Subtract from 180, and we get 32 down here. Okay, we still need lots of other things. So we want to find all the missing angles. So let's start with this angle right in here. So angle ZYX right there. Who can tell me how to get ZYX? Couldn't I just do 180 minus 56? What are those pairs called? They're linear pairs. So I'm going to do 180 minus 56, and I get 124. So right in here I have 124. Okay, can I find any other angles? So 124 plus 32 is 156. So I'm doing 180 minus the sum of 124 and 32, which was 156. So I get 24 in there. It's a little messy. Do you guys see it, 24? What about over here? This is also 24. Do you think, am I pointing at another one? Are you thinking this one? Yeah. So this is 156, good. And then are we good? Almost. Got one more angle. Did you guys see the one little angle? It's right in there. I need these pictures to be bigger. So how do I get this angle right here? So ZJR, or ZJX. So 180 minus 59. So 180 minus 59, so 121. So that's that one. Do you guys see that? One thing at a time. All right, so on this one we know that FD is congruent to, or sorry, F and D are congruent to each other, so we have that. I remember this one being tricky. Okay, so let's start with what we know. So how about this angle right here by 147? So 147, if I subtract that from 180, I get 33 degrees. I'm going to put in X's for angle F and angle D, because I don't know what they are. But I do know that this triangle that's on the right side, I guess I didn't need to do X's. I have 33 added to 90 added to X has to equal 180. Did you guys see that? So when I find that, I get X equals 57. x is 57. So that means that f is also 57. So are we able to get the question mark one now? Yeah, we have this triangle right here. So we have 63, 57 in the question mark. I'll just put question mark equals 180. So 180 minus, we're going to subtract out the 57 and subtract out the 63. So we get question mark equals 60. So that's what that angle was. So measure of angle FCA equals 60 degrees. Okay, does this make sense? Do you guys see how the overlapping triangles work? So just look for triangles within big triangles. Okay, and the last one. So it says write a statements and reasons proof. This is a tough one. So let's kind of go through. We don't have to write the whole proof out, but let's draw some things in. So maybe I'll make this a little bigger. Can I make it bigger? Now I stretched it out. Funny. All right, anyway, so we have BA is perpendicular to AD, and CD is perpendicular to DA. We have AF is congruent to DE. We have BE is congruent to CF. It's always hard to do ones where they go across different lines. We want to prove that ABE is congruent to DCF. So we don't have to do the formal proof, but kind of explain to me why this would have to be true. So we have a 90-degree angle. So if we're trying to prove triangles are congruent, a lot of times we can use hypotenuse leg. Would this be a hypotenuse leg one? Yeah, it looks like it's going to be, but it's not quite there yet, right? Because we have the hypotenuse for each one. These two are congruent to each other. But we don't quite have the leg. We only have this part of it instead of going all the way to here. So tell me how we would work this out. Like, how would we do this in the proof? What would we need to add to get this whole thing? FE. So it's going to involve that segment addition postulate. Does that make sense? So you would add FE to both sides. That would be the addition property of equality. So you'd have like AF plus FD equals DE plus FE. What did I say? AF plus FE equals ED plus FE. Right? You'd add FE to both sides. And then you'd be like, well, this whole thing now is now this segment AE. And this other whole thing is now the segment DF. Right? Does that make sense? So you'd have to go through addition property of equality, you'd have to do segment addition postulate in order to get that those legs are congruent. Then once you have that, you can say that the triangles are congruent by hypotenuse leg. So it's really not that bad, I guess, but it does involve the segment addition postulate. All right, so let's stop there.